It's a pleasure to be here to present on diet and cardiovascular disease and some of the work that we've conducted over the last 5 years with the Global Pure Study. Oh.
I'm just giving you a timer.
Right. Yeah. Oh, great. Okay. Now, you all know the diet-heart hypothesis, so I'm not going to repeat that so I could spend more time on Pure, so I'll just jump right to it. Okay, now, last year we published 3 papers that appeared in the Lancet and Lancet Diabetes Endocrinology. Now, the first of our papers, we looked at the association of dietary nutrients with blood lipids and blood pressure, looking at 18 countries around the world. Now, this is the cross-sectional analysis of the Pure data. So I'll tell you more about Pure. Now, Pure is a large global prospective cohort study from 667 communities in 18 countries around the world, spanning 5 continents. So because the study is global, it captures broad patterns of diet globally across a broad range of intakes, so from very low levels to very high levels. So in doing that, you're able to characterize the shapes of relationships between nutrients or foods and health outcomes, which has never been characterized across a broad range and with high statistical precision ever before. Now, here are the countries that are part of Pure by geographic regions, including South Asia, China, Southeast Asia, Africa, North America and Europe, Middle East, and South America. Now, this is the cross-sectional analysis of Pure. The participants are from the general population, free-living populations in the community in 18 countries, 135,000 people aged 35 to 70 years without cardiovascular disease at baseline. Diet was assessed using country-specific validated food frequency questionnaires, and we measured all known confounders like demographics, lifestyle like physical activity, smoking, alcohol intake, health history, and study center as well. And we had data on blood pressure in 125,000 people, blood lipids in 104,000, and ApoB and ApoA in 18,000 people. And we used standard statistical methods to analyze the data. So you could see here, we look at the results for saturated fat versus the blood lipids. So the top left, you see the results for saturated fat versus LDL cholesterol. And you can see across a broad range from less than 4% of energy from saturated fat to 11%, we see a positive association with higher saturated fat, higher LDL cholesterol, which is consistent with what we know from randomized trials, which relatively speaks to a modest effect. You look at the change from 2.8 to 3.2 across a big change in saturated fat, consistent with the Hooper meta-analysis. But we also see an increase in HDL cholesterol. And when you take the ratio here in the bottom left of total cholesterol to HDL, you see an inverse association. Now, we know from large epidemiological studies that total cholesterol to HDL ratio is a stronger risk marker of future cardiovascular events compared to LDL cholesterol alone. So this would suggest a beneficial effect. Then on the bottom right, you see ApoB, ApoA ratio. We see higher saturated fat related to lower ApoB, ApoA. And we know from the InterHeart and InterStroke study, 2 global studies of heart attacks and stroke, that ApoB and ApoA ratio was the strongest lipid marker of future cardiovascular events, stronger than LDL cholesterol, much stronger. And it was the strongest biomarker that related to future events. So this would suggest a beneficial effect of saturated fat when we look at ApoB to ApoA. So if you're focusing on LDL, the advice you give to the population is to reduce saturated fat. And that's what the guidelines do. But when you look at the other risk markers, you get a completely different story. So what can you make out of this? Well, bottom line is really you need to look at actual clinical events, heart attack, stroke, death. And and for carbohydrates, we see the opposite. We see with higher carb intake, we see lower LDL, but we see lower HDL. And an increase in total cholesterol to HDL ratio would suggest a harmful effect. When you look at ApoB, ApoA, we see an increase in the ratio with higher carbohydrate intake. So it's the complete flip side of what you get for saturated fat. So again, we've been focusing on LDL, top left, getting people to replace fats with carbs, but, traditionally in dietary advice. But when you look at the other markers, you get a completely different story. Now, there's been a series of meta-analysis published over the last 10 years. These are the most recent ones looking at randomized controlled trials where they replace saturated fat with polyunsaturated fat, really a direct test of the diet-heart hypothesis. And you can see from these meta-analyses that generally when you crunch the data from these randomized trials, you get neutrality. No significant benefit in replacing saturated fat with polyunsaturated fat. Then 3 years ago, we published a meta-analysis of prospective cohort studies looking at the relationship of saturated fat with coronary heart disease. And now the advantage of looking at cohort studies over randomized trials is you look at long-term dietary exposure, whereas randomized trials is relatively short-term exposure. And of course, there are also limitations with epidemiological studies, which I won't get into today. But you look at the data from these prospective cohort studies, looking at lowest and highest intake groups, you see no relationship between saturated fat and the various health outcomes, including mortality, coronary heart disease, cardiovascular mortality, ischemic stroke, and type 2 diabetes. Okay, that brings us to the second of our papers published last year, this one looking at the clinical events, the nutrients versus heart attack, stroke, and mortality. And so now we're looking at the prospective cohort data in PURE, 18 countries, 135,000 people. During the course of the follow-up, we accrued more than 4,700 major cardiovascular events and more than 5,700 total deaths during a follow-up period of 7.4 years. And we use standard multivariable Cox regression to analyze the data with study center as a random intercept. And here you see the results for the risk of mortality shown on the left and major cardiovascular events on the right by macronutrient intake. So first on the left, you could see with higher carb intake from 46% of energy to 77% of energy, we see an increase in the risk of mortality with higher carb intake. For total fat and protein, we see the reverse. We see higher intake is associated with a lower risk of mortality. On the right, we see that each of the nutrients generally has a pretty neutral effect on major cardiovascular events. Then we looked at the various types of fat versus mortality and major cardiovascular events. So on the left, looking at total mortality, we see saturated fat, monounsaturated, and polyunsaturated each are associated with a lower risk of mortality. On the right, looking at major cardiovascular events, we see that the results are pretty neutral. We see no significant association. So then we subdivided. We looked at the types of death. We looked at cardiovascular death on the left and non-cardiovascular death on the right. So first, for focusing on cardiovascular death, we see with higher carb intake, we see an increase in the risk for cardiovascular disease mortality that trended towards significance. But we see the reverse pattern for total fat and protein, where higher fat and protein intake was trended toward a lower risk of cardiovascular death. For non-cardiovascular death, which in PURE is largely represented by cancer and respiratory outcomes, the most common, and there are others as well, but those are the most common, cancer and respiratory. You see that with higher carb intake, you see an increase in the risk of mortality, looks dose-dependent, whereas for total fat and protein, we see the reverse. Fat and protein are associated with lower risk. And then when we look at the types of fat, on the left, we see with higher saturated fat, mono and polyunsaturated fat, there's a pattern suggests a protective effect against cardiovascular disease death. And on the right, similarly, we see higher intake of saturated and polyunsaturated, monounsaturated also is associated with a lower risk of non-cardiovascular death. So this suggests a protective effect for the various types of fats versus CBD and non-CBD, whereas for carbs, you get the complete opposite. Okay, and now the third paper that we published last year, this one in The Lancet by my PhD student, Victoria Miller, who just graduated, by the way, with her PhD. We looked at fruit, vegetable, and legume intake and cardiovascular disease and deaths in 18 countries. In the interest of time, I can only show one slide on that. But generally what we found was higher fruit, vegetable, and legume intake was associated with a lower risk of mortality and a lower risk, well, a trend for a lower risk with major CVD, but that's not quite clear-cut, so more neutral than protective. But for total mortality, we see a protective effect with a maximal benefit at 3 to 4 servings per day. Now, it's important to point out that pure largely represents countries around the world where in large parts of the world, people eat predominantly carbs that are refined grains and added sugar. So fruit and vegetables represents only a small component of carb intake. I'm not showing the distribution today in the interest of time, but it was less than 10% of the carb intake was fruit and vegetables. So the other carbs largely explain the harmful effect that we see for carbs. This is not moving here. That's strange. Oh, there we go. Did I miss one? No, okay. Went back there. Okay, there we go, it's slow. Okay, so to summarize, a high carbohydrate diet exceeding about 50-55% of energy is associated with increased risk of mortality. Various types of fats, including saturated and unsaturated, are associated with lower risk of mortality. No association between total fat, types of fat, and cardiovascular events. We did see that saturated fat was associated with a lower risk of stroke, which is also consistent with prospective cohort studies. So the current advice to limit total fat to less than 30% of energy and saturated fat to less than 10% is not supported by this global study. So we recommend that people eat fruit, vegetables, nuts, legumes, dairy, and meats, and to eat less refined grains, sugar, processed meats, and sweetened drinks, and to avoid industrial trans fat. So the rest of my talk will focus on salt. We've done a lot of work on salt, which is the other so-called holy grail nutrient for reducing cardiovascular disease in populations. Just real briefly, salt intake is related, the hypothesis states that salt intake is related to raised blood pressure, and raised blood pressure is a risk factor for heart attack, stroke, and death. So if we reduce salt intake in the population, we'll also reduce heart attack, stroke, and death in the population as well. Now, of course, this assumes that sodium affects only blood pressure and has no other biological effects in the body. And of course, it doesn't quite work out that way. And that's why I'm here. It's not moving. There we go. So just briefly, the current guidelines on salt by the WHO and also other guidelines like AHA recommend a very low amount of salt, between less than 2 grams per day to 2.4 grams per day, which is only about 1 teaspoon of table salt. That's a very low amount of salt, very difficult for most people to sustain in the short term, let alone in the long term. And some guidelines, like AHA, recommend even lower amounts for high-risk people, less than 1.5 grams per day, which is only 0.7 teaspoons of salt per day. This is slow, okay. Now, in the interest of time, I can't really get much into the literature, but in general, studies of general populations looking at sodium versus blood pressure have found weak relationships between sodium and blood pressure. So the most widely cited study has been the InterSalt study published BMJ in 1988. They found about a 1 millimeter mercury increase in systolic pressure per gram. But an equally well-conducted study in Scotland, published in the same issue of the BMJ as InterSalt, found no relationship between sodium and blood pressure. But it's InterSalt that gets widely quoted. And more recently, InterMap, study of 17 centers in 4 countries, also found no relationship between sodium and blood pressure. These are studies that use 24-hour urine collections to measure sodium. Now, the DASH trial is the primary basis for the current AHA guidelines and the dietary guidelines on sodium. But it's important to point out that the DASH trial was a proof of concept study as to whether changes in multiple aspects of the diet, including sodium, reduce blood pressure. and that the meals were provided to participants over the course of 5 weeks. So this was a short-term feeding study to look at short-term effects on blood pressure. It was not designed to assess if sodium also reduces cardiovascular disease and mortality in general populations. And there were also other issues with the DASH trial that I won't get into today, but are covered in many of our review papers. Okay, now the bread and butter of epidemiology is measurement, the measurement of the dietary exposure. Now, 24-hour urine collection is the reference method for assessing sodium intake in individuals, but it's not feasible in large-scale studies. And under-collection is a problem, and so is selection bias. Because of the high subject burden in doing 24-hour urine collections, you get high non-participation rates. So we need simpler methods to assess intake in large population studies. Fasting morning urine has been validated versus 24-hour urine collections, and also has been shown to be associated with blood pressure with slopes identical to randomized trials. So for example, here's data in 133,000 people that we published across pooling data from 4 studies spanning more than 50 countries. And we applied our method because we had morning fasting urines collected in all these individuals versus systolic blood pressure. Red is people with hypertension, blue is people without hypertension. You can see that you see a positive association between sodium and systolic blood pressure in both the hypertensives and non-hypertensives, with a slope that's twice as steep in hypertensives, consistent with what we know, and slopes of association that are also consistent with randomized trials. So for use in large populations to stratify individuals, to look at relationships with clinical events, this is a very valid method that could be applied widely. That brings us to the first paper that we published in New England Journal 2014. We looked at sodium and potassium versus blood pressure. And in the interest of time, I'm going to skip a few of these slides and get to this one here I wanted to point out. Now, this slide here shows the frequency distribution of sodium intake around the world in 100,000 people spanning 5 continents. The red curve shows observed sodium excretion based on a single urine measurement. The blue curve represents usual intake after adjusting for random error. And you can see overall the average sodium intake in the global population is 4.9 grams per day. And you'll also note that the US average is markedly lower than the global population average. So it's not like we're consuming like higher amounts than other countries. Where if anything, we're markedly lower than the global average of 3.5 grams per day. You'll also note that looking at the 2.3 gram recommendation, less than 3% of the global sample meets that 2.3 gram recommendation. And when you adjust for random error, less than 1% meets the recommendation. And when we look at the 1.5 gram per day cutoff specified by the AHA, less than 1% meet that recommendation. And when we adjust for random error, nobody meets that recommendation. So in other words, what we currently recommend is what nobody eats. So the human experience for low sodium is extremely sparse. Now, the other important point is that China has a markedly higher level of sodium compared to most other countries of the world. And that's an important point to make, as you'll see with the data later. So China's average is 5.6 grams per day, whereas most other countries are below 5 grams per day, an average of about 4.4 grams per day. Potassium intake, though, is pretty similar. Now, sodium is an essential nutrient. We know every essential nutrient follows a U-shaped relationship with health. And sodium is no different. It's an essential nutrient. The body needs sodium. It's not like tobacco, where we know the optimal level is 0. Sodium you need. And we know at high levels you get toxicity. At low levels you get deficiency. So there's always a sweet spot in the middle for every essential nutrient. It's not moving. Strange. There we go. Okay, so that brings us to the first of our papers where we looked at clinical events. This is on target. People with vascular disease followed up for about 5 years. and 28,000 people, more than 4,700 clinical events occurred during the follow-up. You could see that on the right, you see the cubic spline curve. When intake exceeds about 6 grams per day, we see an increase in risk. At the low end, when intake is below 3 grams per day, we also see an increased risk. So there's a sweet spot between about 3 to 6 grams per day associated with the lowest risk, which is consistent with any essential nutrient. Note that the US average is currently at the lower end of the sweet spot, which means that we're eating about the right amount that we should be. Now, if we were to reduce intake to the currently recommended level for vascular patients, we would actually put people at increased risk. Now, on target is people with vascular disease. What about general populations? So that brings us to the second of our papers published in New England Journal 2014. Here we looked at sodium and potassium versus cardiovascular events. Over 100,000 people from the 18 countries. We accrued more than 3,300 major cardiovascular events during the follow-up. At that time, follow-up was 3.7 years. Well, went too far. There we go. Okay. Now, this slide summarizes the results for the various outcomes. The primary composite outcome of major cardiovascular disease and death, total deaths on the top right, and at the bottom we have major cardiovascular disease. And you could see a similar pattern of results. Again, a sweet spot in the middle, high intake, you see an increased risk, about 6 grams per day and higher. Low intake, we see an increased risk, even more, less than 3 grams per day associated with increased risk. So between 3 to 6 grams we found to be optimal. Note the US average, again, is at the lowest part of that sweet spot. Okay, I've got here 8 minutes. Okay. Okay, I don't have time to get into the extensive analyses that we did, but I'll just say that no matter how you analyze the data, every humanly way possible, the results would not go away. We did extensive adjustment for all known confounders. We excluded people with cardiovascular disease, cancer, people with an event in the first 24 months. Again, we see that low sodium is associated with increased risk compared to moderate sodium intake. For potassium, we see clearly a protective effect, higher potassium associated with lower risk. We got very favorable commentaries from various journals, including New England Journal. Susan Opperl, who is the former head of the American Heart Association, had a very positive commentary on our paper. Now, despite what you might see some individuals out there trying to portray that it's only pure, other studies have shown exactly the same thing, including studies that use 24-hour urine collections, including people with type 1 diabetes, type 2 diabetes, people from the general population in Europe, and people with chronic kidney disease, either a J-shaped relationship or an inverse association. Actually, an inverse association, higher sodium related to lower risk of cardiovascular events or death. And this is consistent across cohort studies where you compare moderate sodium to low sodium. Each and every time, moderate sodium does better. High sodium, when you go above 5 grams per day compared to moderate, we see an increased risk. So Grotto in his meta-analysis identified a sweet spot between 2.7 to 5 grams per day. If you go above that or below that, you see an increased risk. And in another paper we published in 2016 in The Lancet, we subdivided people with hypertension and without hypertension. And the point I want to make here is that overall, you see, again, a U-shaped curve on 133,000 people pooling data across 4 studies from the general population and people with cardiovascular disease history. And on the left and right here, you see hypertension and no hypertension. The point here is that regardless of blood pressure status, again, you see low sodium is associated with increased risk of major cardiovascular events and death compared to moderate sodium. So regardless of whether you have high blood pressure or normal blood pressure, low sodium is associated with harm. Remarkable consistency across subpopulations. And now, why would low sodium be harmful? We know that low sodium is a predictor of higher renin and aldosterone levels. Intervention trials have also shown that lowering sodium intake increases renin and aldosterone and activates the renin and angiotensin system. We know these are vascular damaging substances. They even have a class of blood pressure drugs directed at blocking this mechanism. Low sodium has been shown to increase these hormones. Now, last week we published a new paper, this one also published in The Lancet. Now this time we look at the community level, over 300 communities around the world. Now first we looked at the center level, urban and rural subcenters, community and individual level. You see similar slopes of relationship between sodium and blood pressure. Again, reaffirming the accuracy of our sodium measurements. Now in the interest of time, I can only point out a few of the community level results. And okay, great, almost done. On the top left, you see major cardiovascular disease. We see generally an increased risk when we go above 5 grams per day, but not below 5 grams. Now, the effect is driven largely by the increase in stroke. But the increase in stroke occurs when sodium goes above 5 grams per day. Remember, that's levels you see in China, where most of the other communities are below 5 grams. In the other countries, you see it's flat. You see no increase in risk. And the one last slide I wanted to show you, which is key. Whoops. Sorry, losing time here. Okay. Then we subdivided China versus the other countries, looking at the biggest signal, which was stroke. And we see that China, most of the communities have an intake above 5 grams per day, whereas in the other countries, we see most communities are below 5 grams per day. And in China, we see a positive association between sodium and stroke. In the other countries, we see, if anything, an inverse association. So it's China that we need to focus on, getting their communities from above 5 grams down to below 5 grams, in that 3 to 5 gram sweet spot. So if this thing will move along, you get to my conclusion. Potassium was beneficial. We see higher potassium related to lower risk. So higher potassium intake was beneficial. But this thing's not moving here, sorry. Why it's not moving? Okay. So sodium greater than 5 grams is associated with increased risk. Such high levels are found mainly in China, less common in other countries. Low sodium is associated with higher risk of mortality. Potassium is associated with low. So rather than a population-wide strategy, we need to target individuals and communities above 5 grams per day. Most people fall in that 3 to 5 gram per day range, which is what they should be eating. And now more people increasingly are starting to agree that large randomized controlled trials are needed to test low sodium versus moderate sodium intake. Sorry, I'm pushing, but this thing's not advancing here. Okay. World Heart Federation called for more randomized controlled trials, to be done. So last slide to conclude. First and foremost, Hippocrates said, do no harm. So the public health has the potential to do great good when it's right, but great harm when it's incorrect. And this is a picture of our Pure Study team in our last meeting in New Delhi, India, in November of last year. Thank you very much. Thank you.
Thank you, Andrew. Very excellent talk on a very important study. So it's my great honor now to introduce our next speaker, who is Dr. Ron Kraus. Where is Dr. Kraus? Okay. Oh, there you are. So he's a legend in the area of lipid research. He's based in San Francisco. And if you read anything in lipid metabolism over the last 2 or 3 decades, you're going to be familiar with Dr. Kraus's work. And he was a pioneer in the elucidation of particle size in terms of lipoproteins. So it's my pleasure to welcome you, Dr. Kraus.